Hi everyone, I am uploading a series of short educational videos describing mathematical theories and formulas with few examples. These are suitable for grades 10 to 12, IB, SL and HL levels, AS and A levels of IGCSE, AP Calculus, AB and BC, and similar other chapters of mathematics for students who are willing to appear in examinations. This video is about binomial theorem. The more videos in this series are coming shortly. My name is Yavar Srivastava. Anyone willing to have one-to-one interaction for details about our live math and physics classes can contact us on our WhatsApp numbers 919972524 or 91821 723 8636. Now, what is binomial expansion? A binomial expansion is an expression with two terms such as x plus h. When we raise it to a power of n, we can expand it into several terms. This expansion follows a fixed pattern given by the binomial theorem. Binomial expansion of x plus h to the power of n is shown here. The concept is formula, examples and applications. The topic expansion of x plus h to the power n using the binomial theorem is presented here. These are useful for algebra, differentiation and approximation. The general formula x plus h to the power of n is equal to nc0 x to the power n plus nc1 x to the power n minus 1 h plus nc2 x to the power n minus 2 h to the power 2 and so on, and the last is ncn h to the power n. Here c, n and r is equal to factorial n upon factorial r times factorial n minus r. The coefficients are called binomial coefficients. First few terms of x plus h to the power n are x plus h to the power n is equal to x to the power n plus n x to the power n minus 1 h plus n into n minus 1 by factorial 2 times x to the power n minus 2 h to the power 2 plus n into n minus 1 into n minus 2 by factorial 3 times x to the power n minus 3 h to the power 3, and the last term is h to the power n. Some patterns are there important to notice in this binomial expansion. Powers of x decrease from n to 0. The first term, the power of x is n, and the last term, the power of x is 0. Powers of h increase from 0 to n. In the first term, h has got a 0 power, and in the last term, h has got a power of n. Number of total terms is equal to n plus 1. Sum of powers is always in each term always remains equals to n. We have taken some examples here. So we are expanding x plus h to the power of 2. So we are getting here is x square plus 2xh plus h to the power 2. Here see the n value of n was 2. So we got 3 terms here, n plus 1 terms. Then the coefficients are for x square is 1, for 2x is 2, and then h square is 1. This is the simplest binomial expansion. Example 2, when we are taking x plus 2 to the power of 3, we are getting x to the power 3, 3x square h plus 3xh square plus h to the power 3. So we are getting 4 terms here. When n is equal to 3, we are getting n plus 1 terms, which is 4. The coefficients are 1, 3, 3, and 1. These coefficients also appear in Pascal's triangle. We will separately make a video for Pascal's triangle and upload. Example 3, we are expanding x plus h to the power 4. we will have 5 terms here because n is equal to 4, so n plus 1 will be 5. So we are getting here x to the power 4, 4x cube h plus 6 h square x square h square plus 4x h to the power 3, and the last one is h to the power 4. The coefficients are 1, 4, 6, 4, and 1. This is useful for pattern recognition and higher algebra. The expansion up to first 2 or 3 terms here shown that because when we go for binomial expansions, all the values of n is not possible to show in one sheet. So we take 2, 3 terms, basic terms from the beginning terms from the expansion. So x plus h to the power n, the two terms are x to the power n plus nx to the power n minus 1 h, and so on. If only first 2 terms are needed, we can stop here. But if more than the 3 terms are needed, then we go for 3 terms. That is x to the power n plus n x to the power n minus 1 h plus n into n minus 1 by factorial 2 x to the power n minus 2 and h square. Now this is used in differentiation. In the first principle of differentiation, we often use f dash x equals to limit h tends to 0, and within bracket we are getting fx plus h minus fx and whole over h. So find x plus f of x plus h, we expand the expressions like x plus h to the power n. So binomial expansion becomes important. Application in first principle we are shown here that let fx equals to x to the power n. Then x plus f of x plus h is equal to f of x plus h to the power n. And so x to the power n plus n x to the power n minus 1 h, and so on. So f of x plus h minus f of x by h is equal to n x to the power n minus 1 times h, and the last term, it goes up to last term, and so we divide it by h. Now taking h tends to 0, it gives a differential of x to the power n over dx equals to n x to the power n minus 1. This has been shown in a separate video of a differential of n x to the power n. The summary says that the binomial expansion helps expand x plus h to the power n systematically. The general term c, n, and r, x to the power n minus r, h to the power r, where the number of terms is equal to 1, n plus 1, are very useful in algebra, calculus, and approximation methods. This video ends here. Short mathematical videos on different chapters shall be uploaded one by one shortly. Request the viewers to like and share these free videos among family members and friends. Also subscribe to the channel SS Academy in and press the bell icon to get notification for upcoming math videos. My name is Yavar Srivastava. Anyone who is willing to have one-to-one interaction for details about our live math and physics classes can contact us on our WhatsApp numbers 919972524525 or 91821723866. Like this video, share it, and subscribe to the channel